Alright guys, so I'm going to talk to you about area today, and area is basically the space inside a shape. So no matter what the shape is, let's see if this will draw for me. No matter what the shape is, we're talking about the area inside. Okay, that's called area. Makes sense, that's the area inside. This portion, that is called perimeter. So in this lesson, we're just talking about area. So looking at area, what you're going to do with the lesson we did today is pretty simple. You're just going to count the square units. So for instance, this one is 1, 2, 3, 4, 5, 6. So the area of this is 6, but you want to make sure to put the unit. So let's act like these are each a square inch. So you would say 6 inches squared, or 6 square inches. Okay, the reason for that is because when we're talking about area, it has 2 dimensions. So that's where that 2 comes in. So if we have this here, let's act like it goes all the way and it's perfect. Okay, it has 2 dimensions. It has height and width. Okay, now if we were talking about a shape like this, we're adding a 3rd dimension. So this would be cubed. But because we're just talking about 2 dimensions in area, we are going to have squared. Okay, so here are some examples that I'm going to show you. First of all, this right here. And again, let's act like that's perfect. So we have 1, 2, 3 across. We have 1, 2, 3, 4 down. So the area equals length times width. So the area is the length, which is 4, times width, which is 3. That equals 12. And again, we're going to act like it's inches. So 12 squared, 12 square inches. Let's check it just by counting them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are pretty straightforward. Count up your squares or multiply. This is part of an expression. So when you see something that says write the expression, what that means is something like this. That's a number sentence or a math expression. Okay, I'm going to show you something that is a little bit more difficult, but we can do it. First of all, it is the same principle, it's the same idea, but just a little bit more difficult. So we're going to act like these are 1/2. So right here I've got 1, 2, 3, and 1/2 by 1, 2, 3, 4. So now my expression would be 3 and 1/2 times 4 equals something. We're going to figure that out. So what I can do is I can count up my squares. I can say 1, 2, 3, and leave that fraction piece for a second. 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know I have 12 whole tiles. I was talking this morning about how my house flooded and we had to figure out how many tiles to put in my hallway. That's what I'm saying. We need 12 whole tiles, but now we need to figure out how many half tiles. So we're going to count, that's 1/2. 2, 3, 4. So when we're doing this with halves, it's pretty easy because we all are used to a half of a cookie or half of a pizza, and we know that 2 halves equals 1 whole. So in this case, these 2 equal 1, so plus 1, and these 2 equal 1, plus 1. 12 plus 1 is 13, plus 1 is 14. So your expression is 3.5 times 4 equals 14. Let's look at one a little bit different. Sorry, I'm thinking too hard. Okay. There we go. We're going to act like this is perfect. Perfectly half. So we have 1, 2, 3 and a half. Apparently I really like 3.5 tonight. And we've got 1, 2, 3, 4, 5. So this time my expression is going to be 3.5 times 5 equals something. Again, we're going to figure that out. So I count up my squares, or I say, okay, 3 times 5 is 15. Let's check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we got that right. Now I'm going to count up my fractional pieces, my fraction pieces. I'm going to count 1, 2, 3, 4, and 5. And this half right here tells me those are each worth 1/2. So I have 1/2 plus 1/2 plus 1/2 plus 1/2. I know it seems like a lot to write, but you'll thank me later. So I know that 1/2 plus 1/2 is 1. So this is 1, and we'll pick these guys. That's 1. And then I've got this half left over. So that's going to be added to my answer. 15 plus 1 is 16, plus 1 is 17, and then I have my half. So in this case, it's not a whole number, but a mixed number that I end up with. I'm going to give you one final example. Let's say that I've got this, and I've got 1, 2, and 1/3, and I've got times 3. My expression is 2 and 1/3 times 3 equals something. When I count 2 times 3, that's 6. Gonna check 1, 2, 3, 4, 5, 6. Then I count my fractional sides. Got 1, 2, 3. But this time, this tells me that those are each worth 1/3. Even though the picture's not perfect, they're worth 1/3. So I have 1/3 plus 1/3 plus 1/3. And like we talked about today, if you add those up, we would end up with 1, 2, 3 thirds, which is the same as 1. So plus 1. 6 plus 1 is 7. Again, don't forget to put your unit. In this case, if we did inches, it would be squared inches or square inches. Okay, if you guys have questions, let me know and I will help you out. Thanks, guys.